Once upon a time, there was a king who wanted to reward a wise man. The wise man made a simple request: some grains of rice that can fill all the squares of a chessboard. Isn't it simple? The wise man wanted to place one grain of rice in the first square, two in the second, and keep on doubling the amount of grain for each subsequent squares. By the time the king reached halfway through the chessboard, he owed all the grains that his entire country could produce. This story shows us how problems that look very simple at the beginning can become very complex. At present, we face a lot of computational challenges, like discovering a new medicine or accurately predicting natural disasters. These problems might appear simple at the beginning, but questions like predicting something or discovering something are really hard for our modern-day computer to solve. They take enormous amount of time and resources. This is where the use of a quantum computer comes in. A quantum computer uses quantum particles, like an electron or a photon, to perform its calculations. These particles are smaller than the size of an atom and exhibit some special properties, like superposition, entanglement, and interference. Because of these special properties, now we can develop a totally new approach to solve these complex problems in an efficient way. So how can we build a quantum computer? Well, one approach will be to capture an electron and try to control its quantum property. We can do this by making a sandwich. But our key ingredient should be atoms of different kinds of semiconducting material. In my sandwich, I have one layer of bread made up of atoms of silicon, which is a semiconductor, and another layer of bread made up of atoms of germanium, which is another kind of semiconductor. And here is my trick. If I can place the layer of germanium exactly on top of my layer of silicon, then we can capture electrons in between the two layers of bread. It is like having something really delicious in between the two layers of bread. Now we have seen how to capture electrons, but this only solves one part of our puzzle. Building a quantum computer also requires understanding how to control the quantum properties of all these electrons. To conclude, building a quantum computer is a complex task. We are not there yet, but if we succeed, it can unlock enormous potential. And this journey is really interesting. Thank you.